Welcome to our deep dive into retrieval augmented generation, or RAG systems. In this video, we'll explore the essential concepts, challenges, and advanced techniques that power modern RAG pipelines. Whether you're building intelligent search, chatbots, or knowledge assistants, understanding RAG is crucial for leveraging large language models with up-to-date context-rich information. Let's start by setting the stage for why RAG matters in today's AI landscape, and what you'll learn in this comprehensive guide. One of the first challenges in RAG systems is the lost-in-the-middle phenomenon. Research shows that large language models are excellent at extracting information from the very beginning or end of their input prompts, but often miss critical details located in the middle. This can lead to incomplete or inaccurate answers, especially when prompts are long. Recognizing this limitation is the first step toward building more reliable RAG systems. To address the lost-in-the-middle issue, several strategies can be applied. First, limit the total number of retrieved contexts to keep prompts concise. Next, place high-confidence results at the top and bottom of the prompt, where the model pays the most attention. Finally, implement a high-quality reranker to prune irrelevant documents, ensuring only the most relevant information is included. These steps help maximize the effectiveness of your RAG pipeline. Reranker is a specialized model that sits between the retrieval and generation stages in a RAG pipeline. After the initial retrieval, the reranker takes the user query in the top and retrieved chunks, say 25, and computes a precise relevance score for each. It then reorders these chunks, allowing only the top K, such as 5, to be passed to the final prompt. This ensures that the language model receives the most relevant and high-quality information for generating its response. Reranker's position in the RAG pipeline is crucial. It operates after the initial vector search, which retrieves a broad set of potentially relevant chunks. The reranker then evaluates and sorts these chunks, passing only the best to the language model. This step acts as a quality filter, ensuring that irrelevant or noisy data doesn't reach the generation stage. The result is more accurate and contextually relevant answers for the end user. Hybrid search combines the strengths of semantic vector search and traditional keyword search, such as BM25. By running both methods simultaneously, you capture both semantic meaning and exact keyword matches. However, since their scoring systems differ, a fusion method is needed to combine results effectively. This approach ensures that your RAG system retrieves the most relevant information, regardless of how the user phrases their query. Merge results from vector and keyword searches. Reciprocal Rank Fusion, or RRF, is used. RRF scores each item based on its rank in the individual result lists, not the raw score values. The formula sums the reciprocal of the rank plus a constant, ensuring that items ranked highly in either list are prioritized. This method balances the strengths of both search approaches, delivering a more comprehensive set of relevant documents to the RAG pipeline. Evaluating a RAG system requires more than just accuracy. The RAG Triad framework assesses three core connections: context relevance, groundedness, and answer relevance. Context relevance checks if retrieved chunks are targeted to the user's query. Groundedness ensures responses are strictly supported by the context, and answer relevance verifies that the answer directly addresses the user's question. This holistic evaluation helps maintain high-quality, trustworthy output. Modern RAG evaluation often uses an LLM as a judge framework. Tools like TrueLens or RAGAs automate the assessment of context relevance, groundedness, and answer relevance. By leveraging language models to evaluate outputs, you can quickly identify weaknesses in your pipeline and iterate on improvements. This approach streamlines the evaluation process and provides consistent, objective feedback on system performance. RAGAS framework is an open-source tool designed to evaluate RAG pipelines without human annotators. It generates synthetic test datasets and produces deterministic numerical scores for metrics like faithfulness, answer relevance, and context recall. By using an independent judge LLM, RAGAS provides a scalable and objective way to measure and improve your RAG system's performance over time. Complex user queries often require multiple retrieval steps. Query decomposition uses an LLM agent to break down a multi-step question into distinct subqueries. For example, comparing the revenue growth of two companies in a given year would be split into separate lookups for each company. The results are then aggregated to form a comprehensive answer, ensuring no critical detail is missed. IDO, or hypothetical document embeddings, is a technique where an LLM generates a hypothetical answer to a user's query, even if it's fabricated. This hypothetical text is then embedded and used to query the vector database. Because the fake answer captures the structure and semantics of a proper response, it often improves retrieval performance by matching text to text instead of question to text. Supporting multi-turn conversations in RAG systems means handling follow-up questions effectively. To do this, you must store the conversation history. Before querying the retriever, a condenser LLM combines the history and the new question into a standalone explicit query. This ensures that context from previous turns is preserved, allowing the system to provide accurate and context-aware answers. Context injection is the process of formatting and inserting retrieved text segments into the LLM prompt. Best practices include using clear separator tags, such as context, or to distinguish context from instructions. It's also important to guide the LLM's behavior with explicit instructions, and to inject metadata like document titles and dates alongside the text. These steps help the model format citations and maintain clarity. Extracting tables from PDFs is a common challenge in RAG pipelines. Standard text parsing often destroys table structure, making the data unreadable. To solve this, use layout-aware vision or PDF parsers like Unstructured or Llama Parse to extract tables in structured markdown or HTML. You can also summarize tables with an LLM and store the summary vector, but always return the raw table in the final prompt for accuracy. Self-RAG is an advanced approach where the system prompts the LLM to generate adaptive reflection tokens during output. The model dynamically decides if retrieval is necessary, judges the usefulness of retrieved pieces, and self-evaluates its own response for factual consistency. This self-reflective process helps ensure that answers are both accurate and relevant, even in complex scenarios. Corrective RAG or CRAG introduces a lightweight evaluator step immediately after retrieval. This evaluator grades the relevance of fetched documents against the query. If confidence is low, the pipeline triggers a fallback path, such as launching an external web search. This dynamic correction mechanism ensures that the system always seeks the best possible context for answering user queries. Prompt injection is a security risk where malicious text and retrieved documents can manipulate the LLM's behavior. For example, a document might instruct the model to ignore previous instructions or provide false information. Recognizing this risk is essential for building secure RAG pipelines, especially in corporate or sensitive environments. Protect against prompt injection. Enforce a strict separation between instructions and context variables in your system architecture. Additionally, use modern guardrail models like Llama Guard to inspect and clean context payloads before passing them to the core generative model. These steps help prevent malicious instructions from influencing the LLM's output. Fine-tuning and RAG serve different purposes. Fine-tuning changes the internal weights of a language model, making it ideal for teaching specific styles, tones, or formats. However, it's less effective for dynamic, rapidly changing factual knowledge. RAG, on the other hand, provides explicit access to external data via prompts, making it easy to update, transparent, and manageable without altering the model's core. Graph RAG combines vector databases with knowledge graphs, which contain structured entities and explicit relationships. This approach is especially useful for top-down global reasoning across large corpora. For example, you can identify common vulnerabilities across all software projects in your codebase, something standard vector searches might miss. Graph RAG enables more sophisticated, entity-based retrieval and reasoning. Corporate environments, document-level security is critical. When indexing documents, save user access control lists, ACLs, as metadata alongside each chunk. When a user submits a query, their verified identity tokens are used to pre-filter results, ensuring users only access data they're cleared to view. This explicit filtering maintains privacy and compliance within your RAG system. Auto-retrieval or self-querying is when an LLM inspects a natural language query, detects metadata components, and translates it into a structured database query. For example, show me the 2023 financial reports for Team Alpha becomes a vector search for financial reports with filters for year and team. This automation streamlines the retrieval process and ensures precise results. Context tuning is a post-processing step that maximizes the informational density of retrieved chunks. Techniques include sentence compression and removing repetitive headers from documents. By optimizing the context before appending it to the prompt, you help the language model focus on the most relevant information, improving both efficiency and answer quality. Latency is a major hurdle when scaling RAG systems. Each query involves multiple sequential steps: network API calls, database lookups, reranking, and text generation. These steps can add up, causing delays for end users. Understanding where latency occurs is the first step toward optimizing your pipeline for speed and responsiveness. Reduce latency, parallelize vector and keyword search executions wherever possible. Implement aggressive application-level caching known as semantic caching to avoid redundant computations. Finally, stream output tokens to the client in real time, so users see answers as they're generated rather than waiting for the entire process to finish. These optimizations make your RAG system more efficient and user-friendly. Semantic caching stores historical user queries and their generated answers in a cached database. When a new query arrives, the system checks its vector similarity to cached queries. If a close match is found, the cached answer is returned instantly, bypassing the entire RAG pipeline. This dramatically reduces latency and improves user experience for repeated or similar queries. A robust RAG pipeline combines all these strategies: effective retrieval, reranking, context injection, and security. By layering these techniques, you create a system that's accurate, efficient, and resilient to both technical and security challenges. Each component plays a vital role in delivering high-quality answers to users. Ultimately, the goal of any RAG system is to provide a seamless user experience. Fast, relevant, and trustworthy answers keep users engaged and satisfied. By focusing on both technical excellence and usability, you ensure your RAG solution meets real-world needs and stands out in a competitive landscape. RAG systems are not set-and-forget solutions. Regularly evaluate your pipeline using frameworks like RAGAS and the RAG Triad. Monitor for new challenges such as emerging security threats or changes in user behavior and iterate on your design. Continuous improvement is key to maintaining a high-performing RAG system. Scaling RAG systems for enterprise use involves handling large volumes of data, complex access controls, and high concurrency. Leverage robust infrastructure, distributed databases, and scalable vector search engines. Ensure your security and compliance measures are up to date to protect sensitive information as your system grows. The future of RAG systems is bright, with ongoing research into more advanced retrieval methods, better evaluation frameworks, and tighter integration with knowledge graphs and external data sources. Staying informed about the latest developments ensures your solutions remain cutting-edge and effective. One of RAG's greatest strengths is its ability to integrate external data sources. Whether you're connecting to internal databases, public APIs, or real-time feeds, RAG systems can pull in the latest information to keep answers current and relevant. This flexibility is a major advantage over static, fine-tuned models. RAG systems offer high transparency and auditability. Because retrieved documents in context are explicitly included in prompts, it's easy to trace where information comes from. This makes it simpler to debug issues, explain answers, and comply with regulatory requirements, key factors for enterprise adoption. RAG systems are cost-effective compared to frequent fine-tuning. Since you don't need to retrain the model for every knowledge update, you save on compute resources and engineering time. Updating your knowledge base is as simple as adding new documents, making RAG a practical choice for dynamic environments. Keeping your RAG system's knowledge base up to date is straightforward. As new information becomes available, simply index new documents and update metadata as needed. This ensures your system always provides the latest, most accurate answers without the need for expensive retraining. Personalization is possible in RAG systems by leveraging user identity and preferences. By storing user profiles and tailoring retrieval to individual needs, you can deliver more relevant and engaging experiences. Always ensure that privacy and security are maintained when handling personal data. Effective monitoring and logging are essential for maintaining RAG systems. Track query patterns, retrieval accuracy, and system performance to identify issues early. Detailed logs also support compliance and help you respond quickly to user feedback or incidents. Security should be a top priority in RAG pipelines. Regularly audit your access controls, sanitize all retrieved content, and keep your guardrail models up to date. By proactively managing security, you protect both your users and your organization from emerging threats. Thorough testing and validation are key to a reliable RAG system. Use synthetic datasets, real-world queries, and automated evaluation frameworks to ensure your pipeline performs as expected. Regular validation helps catch issues before they impact users. Building and maintaining RAG systems is a collaborative effort. Involve data engineers, domain experts, and security professionals to ensure all aspects of the pipeline are robust. Teamwork accelerates problem-solving and leads to better outcomes for your users. Comprehensive documentation and knowledge sharing are vital for long-term success. Document your pipeline architecture, evaluation methods, and troubleshooting steps. Sharing knowledge within your team helps onboard new members and ensures continuity as your system evolves. The field of RAG is rapidly evolving. Stay current by following research, attending conferences, and participating in the community. Adopting new techniques and tools keeps your system competitive and ensures you're ready for future challenges. In summary, building effective RAG systems involves mastering retrieval, reranking, context management, evaluation, and security. By applying the strategies covered in this video, you'll be well equipped to design robust, scalable, and user-friendly RAG pipelines. Remember, continuous learning and improvement are essential for long-term success. Thank you for joining this journey into RAG systems. As you move forward, experiment with the concepts and tools introduced here. Collaborate with your team, stay curious, and keep refining your approach. The world of retrieval augmented generation is full of opportunities for innovation and impact.